Hello everyone. In today's video, we're going to talk about exponential function. So here is an example for exponential function. So there are two complaints. Complaint A has 100 store and each year is going to be expands 50 new store. And then complaint B also has 100 store to start with, but each year complaint B is going to increase the number of store by 50% of their total each year. So now let's compare the growth of these two stores. So at beginning, complaint A and complaint B. So at beginning, they both have 100 store. And then after first year, complaint A expanded a 50 store. So how many stores in complaint A? Should be 100 plus 50, right? Should be 150. Okay, for complaint B is going to expand by 50% of their total, so should be 100% times 50. That's how much they expand. You still need to add what you have from the previous year. So that means also 150 stores. Okay, for the second year, complaint A is going to expand another 50 store, which is 200 store by the end of the second year. However, complaint B is going to grow by 50% of what you have from the previous year, so which means is 150 times 50% plus 150, which gives you 225. Okay, so on the third year, complaint A is going to expand another 50 store. So by the end of the third year, complaint A is going to have 250 store. But complaint B is going to be what you have from the last year and increased by 50%. So you end up to have a 337.5 stores, and then we're going to round up. So notice that the percentage growth each year, the complaint grows by 50% of the current year totals. So the complaint B is going to grow faster, right? The way that the complaint grow, we will say, hey, this is going to be an exponential growth. So let's summarize it. What does this look like? So if we write it in a function, we have for complaint A is a linear growth. So complaint A, the store number is going to be 100 plus each year is 50, and then x be the number of years. So for complaint B is, we know that it's going to grow 50%. So what does that look like? Well, let's rewrite this. So now just look at complaint B. 100 times 50% plus 100. If we write it, we will have 100 times 1, let's say 0.5 plus 1, right? That's how you represent it. You factor 100 out. Okay, so now we do the same thing for 150. So 150 is equals to 100 times 0.5 plus 1. And also 150, we can write it as 0.5 plus 1, factor 150 out. Since 150 equals to this number, so that means I can write 150 as 100 times 0.5 plus 1. That's our 150, and times 0.5 plus 1. Which means if you have a 2.5 plus 1, that means I can write it as an exponential, which is 100 times 0.5 plus 1, and then square. Okay, so in here, we use the same way. So we have 225 is equals to 0.5 plus 1, right? Because we factor the 225 out. This is equals to 337.5. And then we know that from the previous step, we have 225, it can be returned as 100 parentheses times 0.5 plus 1 to the second power. So now I replace that with 100 times 0.5 plus 1 squared times 0.5 plus 1, because this part is 225. So that means I'm replacing this part. Okay, so now we merge these two together since they have the same base. So that means I can write it as 100 times 0.5 plus 1 to the third power. Okay, so if we summarize it, if you take a look. So at year first, the first year, your function like this one with a base 0.5 plus 1 to the exponent 1. And then for the second year, you have the exponent was 2. And to the third year, you have the exponent equals to 3. So that means your growth function should look like 100 times 0.5 plus 1 to the x power. So in general, more general, we will write it as 100, 1 plus 0.5 to the x, where 0.5 is the growth rate. Because we know that company B is growing 50%, which means it's 0.5. Okay, so in general, this is a form of an exponential function. So sometimes they could be decay. If they shut down 50% of company each year, then instead of plus 0.5, we're going to be minus 0.5. So in general, an exponential growth or decay, if they decreasing, we call it decay. Or decay function. That is a function that grows or shrinks at a constant percent growth rate. Okay, so the equation can be written in the form of fx equals to a times 1 plus the rate to the x. Our variable x is going to be on the top. Or sometimes you will see fx equals to a times b, the base, to the x, where we write b equals to 1 plus r. Okay, so how do we read this function? Our a is going to be our initial or starting value. R is the growth or decay rate. Remember, if it's decay, it will be a negative number. You have to written it in a decimal form. And B is the growth factor or multiplier. So in our case, our company B case, look, the initial value is 100, right? So the growth factor is going to be our B, whatever inside the parentheses. It's 1.5 is our B growth factor, and then our X is the variable. Okay, so let's take a look at this function. Write the exponential function for the Indians population and use it to predict the population in 2020. At the beginning of the chapter, we were given the Indians population. We haven't talked about that. So the Indian population is 1.14 billion in the year of 2008, and the percent growth rate of 1.34%, using 2008 as our starting time, t equals to 0, and our initial population will be 1.14. And then how do we write a function about that? Well, we know that, hey, we have to use 2008 as our initial value. So that means when x equals to 0, our fx, the initial value, is equal to 1.14 billion. And I know that the rate is equals to 1.34%, which is, we convert this into a decimal, should be 0.0134. Okay, so how can I write it? We know that an exponential function should be in the form fx equals to a times 1 plus the rate to x. And the a is the initial value. If we let 2008 to be starting time, so that means our initial value is going to be 1.14 times 1 plus the rate to x. So this is our function for the Indian population. And they want us to predict the population in 2020, since t equals to 2008, we let this to be initial value. So that means when t equals to 2008, when the time is equal to 2008, x is equal to 0. So that means in year 2020, x is going to equal to 12. So that means I want to find f of 12 equals to what? So I have 1.14 times 1 plus this number to 12. And you use a calculator to calculate that. Remember, you need to follow the order of Pendex. So you need to calculate everything inside the parentheses first, and then exponential, and then do the multiplication. All right, so now I'm going to skip in the calculation. So this is going to be 1.337 billion in the year 2020. So here's another example. A bismuth-210 is an isotope that radioactively decayed by about 13% each day, meaning that 13% of the remaining bismuth-210 transform into another atom. If you begin with 100 milligrams of bismuth-210, how much remained after 1 week? Okay, so now let's set up the equation first. We know that the initial value is A equals to 100 milligrams, and the decay rate is 13%. So that means R equals to negative 0.13. We need to remember that. If it's decay, it has to be negative, and we also need to convert it to a decimals. All right. So now we have the function fx of a times 1 plus r to the x. And a is equal to 100 milligrams. And the 1 plus r, remember, this is a decay. So that's why we need to use subtract the rate to x. X is the time. All right, so we know that the decay rate is by day, counted by day, it's 13% per day. So now they ask you how much remains after a week. So 1 week is equal to 7 days. So that means they ask you to get f of 7 equals to what? So I have 100 times 1 minus 0.3 to the 7 power of 7. Okay, so when you calculate that, so this should equals to 13.7 8.73 milligram. Calculated by calculator. Okay, so what if I'm giving you 2 points and I want you to find the function? So let me find an example. So for example, in this one, in 2009, 18 deer were reintroduced in the wildlife refugee area from which the population had previously been hunted to elimination. By 2015, the population had grown to 118 deer. If this population grows exponentially, find the formula for the function. Okay, so we know that the function is going to be fx equals to a times 1 plus r to the x. All right, so now if we take a look at here, they're giving you in 2009, you have 18 deer, and then by 2015 you have what, 118 deer. So to set up this question, if we want to find the function, we need to solve a and r, and they're giving you 2 points. So well, the easiest way to do it is we let 2009 to become the initial year, because in this case we know that when x equals 0, fx equals to 18, so that by the year 2015, that means 6 years pass, fx is equal to 180. So with that, we might be able to solve the question. So if the initial year is 2009, so that means the initial value is equal to 18. So I will have fx equals to 18, 1 plus r to the x. And then if we substitute 6, 180 into the function, I have f of 6 equals to 18, 1 plus r to the 6 equals to 180. So now how do I solve that? Well, the first step is you want to divide it by 80 on both sides. So I have 1 plus r to the 6 equals to 9/4. Okay, so you have the power of 6. So in order to get rid of power, you can take the square root, 6th root, not square root, the 6th root on both sides. So you'll have 1 plus r equals to 9/4 to the 6th root. Okay, so in calculator, how do you put in 6th root? If you don't have a scientific calculator, you only have Google calculator, the most basic one. Well, what you can do is think about the power. Instead of putting the 6th root, you can put 6th root is equal to the power 1 to the 6th. So that means I'm going to show you how to do it with a Google calculator. So that means if you open a Google calculator, you will put 9 divided by 4, which is the base, and to exponent, which is, you find the exponent and you put a parenthesis and put 1/6, which means 1 divided by 6. So that's how you put in there in your Google calculator. So we get 1.1447. Okay, so I have 1 plus r equals to 1.1447. Okay, we keep 4 decimal places. And then when we minus 1 on both sides, I got r is equal to 1.01447. So that means our function is going to be fx a equals to 80, 1 plus 0.1447 to x. That would be our function. So this is similar if I tell you that, hey, find a formula for exponential function passing through 2 points, but I didn't give you the initial value. What would you do? Well, we know that if they get, you know that this point is going to passing through a exponential function, you know that the function is going to be fx equals to a times 1 plus r to the x. We need to solve a and r by 2 points. So f of 2 equals to a times 1 plus r to the x equals to 6. The other one is f of negative 2, sorry. F of negative 2. The second one is f of 2, 1 plus r to the 2 is equals to 1. So given these two, how do you do that? Well, you just need to use A, solve for A first, or solve for B first. Basically is you trying to use substitution approach, solving one equation for a variable, then substitute that expression into the second equation. For example, from the first one, I can solve A by dividing A on both sides, right? So I will have A equals to 6 divided by 1 plus r to the negative 2 power. And then I substitute the a into the second function here. In that case, I will have 6 over 1 plus r to the negative 2, and then 1 plus r to the second power equals 1. Okay, so this is equals to what? Well, this is going to equals to positive 4. I have 6 times 1 plus r to the 4th power equals to 6. And then divided by 6 on both sides. So you will have 1 6. 1 plus r to the 4th power equals to 1 6. And then you take the 4th root, which means if you have a decimal, you're going to raise this to 1/4 power. Oh, you have a calculator. You can use a decimal calculator or GeoGebra calculator or Google calculator. That's why I say decimal earlier. Decimal is also a calculator or your scientific calculator. So the power will cancel. All right, so that our r is going to be 1 6 to the 1/4 power minus 1. Okay, so then we solve for r. Our r is going to be, r is equals to 0.3611. Okay, after we solve for r, we substitute r into our function, try to find our initial value. So let's substitute r into the second function or the first one. It doesn't matter. It will work. So that means I have a times 1 plus, minus, I'm sorry. This is negative. I got a negative. So I will have 1 minus a times 1 minus 0.3611 to the 2 power is equal to 1. And now we can solve a. So I will get a is equal to 2.4492. I'm going to skip the algebraic here. So that after we have a and r, we can have our equation for this. We will have an equation for this function, which is passing through the point -2, 6, 2, and 1. So our function is going to be fx equals to 2.4492 times 1 minus our rate to x. So if instead of giving you 2 points, they're giving you a graph, the approach is the same. That you find 2 points on the graph and then substitute into the exponential function and use the exponential function to solve a and the r.